All right, hello. Excuse me. So today we're going to be focusing on cyclohexanes, specifically how to draw chair conformers. And then I'm also going to give you the ins and outs and the basic information that you will have to know about such conformers, including the stability and including things like chair flips and how that may or may not impact stability. So first of all, I'm going to start out by just drawing by teaching you all how to draw the cyclohexane. So a cyclohexane is a cyclical molecule. So that basically means that it'll be in some kind of a ring, and because it's in a ring and because it's hex, we know that we're going to have a hexagon. So if I draw a hexagon right here, so so that's your generic hexagon. Okay. Now the fact is, if we're to draw this in the chair conformation, we can just draw it like this. And this is something that's very important for you to all understand. So the first part is we're going to draw a right-leaning chair conformer. So what we're going to do is we're going to start out by making one that's like this. So you go up like that, and then you go up like that. And please notice that these lines are both parallel, okay? And then what we're going to do is then we're going to make this line short, but we're going to make it long enough that it's still longer than this line. So what I'm saying, so you want to make this line short, but then because you made this line short, you would need to make this line long, okay? Now, in the other case, you need to do the opposite. So here we made this one short, we made this one long, so now we're going to have to make this one long. And then, of course, this one will have to be short. And you can feel free to extend the lines, okay? So this is how you draw. This is how you draw this. Now let's say that this thing has substituents, okay? So now we have to know where the positions of the substituents. So the positions of the substituents are either going to be axial or they're going to be equatorial. So axial would be like so there's axial and there's equatorial, okay? Now, I'm going to put a check mark by equatorial because it's always more stable when things are in an equatorial position. But anyway, before that, I'm going to show you all how to simply draw the just how to draw the equatorial and the axial substituents. So the nice thing about the axial substituents is that they will always be straight up. Okay, so basically this is going to be straight up, and then this is also going to be straight up. Okay, so this is straight up. Okay, and all right, and then this is going to be straight down, and this is going to be straight down. Okay, so you have that. You have almost all of your axial positions. You have one of which is straight up, and the other of which is straight down. Now there are two more axial positions that you all should know about. And one is going to be up and one is going to be down. So it turns out that this one is going to go up, okay, and this one is going to go down. All right, so now we have all of the axial substituents. Now we just need the equatorial ones, And so the nice thing about the equatorial ones are that there's two types of equatorial ones. There's ones that pinch in, and then there's ones that are parallel to the sides of the chair. So what I mean by that is first I'm going to draw the pinching in ones, and hopefully you'll be able to see why this means pinching in. So here, pinch in, all right? Now, so I did the pinching in for here. Okay, now I'm going to do the pinching in for the other side. So, pinch in, okay? All right, now there's two more things I have to draw. I have to draw two more equatorial ones, one of which is gonna be like this, and the other of which is gonna be like this. Now, how did I know to draw those? Well, notice that this is parallel with this. Okay, so these are both parallel, all right? And then this is parallel with this. And of course, this line and this line and this line and that line, those are all parallel. Okay, so that's an easy way to remember. So just to recap, when drawing the substituents, so you have your axial here. So the blue is going to be the axial. Okay. Axial, okay? And then the red is going to be the equatorial. So you have your equatorial here, your equatorial here, your equatorial here, equatorial here, equatorial here, and equatorial here. Okay, so hopefully, you all can see that now. So whereby the blue is the axial and the red is the equatorial. Okay, so that's how you draw. That's how you draw a right-leaning chair conformation. Okay, so now what I'm going to do is I'm going to draw a left-leaning chair conformation, and I'm going to draw this. I'll draw it on this side, okay? So I'll draw it over there. So this is going to be a left-leaning one. So previously we had this one. So by left-leaning, what I mean that this is going to be going to the left, leaning to the left, and then this is also leaning to the left, okay? Now, I'm going to make this line up here has to be short, but not short enough but long enough that this is still longer than this. And then this is going to be long. Okay? Now this has to be long, and this has to be short. Okay? Now we add on the substituents. So I think blue was our axial substituents. So the blue is going to be the same, or I'm sorry, the axial and equatorial, they're all going to be relatively the same, because axial is always going to be straight up or straight down. This one is straight up, this one is straight down, and this one is going to be straight down, and this one is going to be straight up. Okay, and then for the equatorial, you have pinch in over here, pinch in over here, and then you have pinch in over here, and you have pinch in over here. Okay, so just to and then actually I forgot some equatorial ones. So then this equatorial position substituent has to be parallel over here. Notice how this is parallel with this. Okay, and then this needs to be parallel with this. So I'm sorry if you were not able to see that the full way, but basically, here's what we have. So we have the blue. We have that the blue was the axial, okay? And notice how the axial is always going straight up or straight down. And then notice how the equatorial is always on an angle. And so the idea is that the equatorial is pinching in right there. It's pinching in over here. And then if you look at the far left of the screen, notice how that red line that I drew, that equatorial substituent is parallel to this line, okay? And then similarly, that line is parallel with that line, okay? So that's how you draw these, all right? It takes practice and whatnot, but that's how you basically draw them up, okay? Yeah.